Okay, so what we are going to learn today is deep, okay, for nested loops, and deep if nested statements. Fine. Okay, and from the next what do you say video of mine lecture, I'm going to copy the code and then explain you, because we have lots more to cover and I cannot type the code in front of you. Fine, but open Roblox, take the new file, and you'll reach here. Okay, scroll down till you see server scripts services. Just click here, select script, remove the code whatever is there, and come back here. Okay, so I'm going to keep the name default, or else if you just click it once or right click and go to rename, like say for example you right click and then find rename here, or see F2, you just click on it and press F2, it's rename, and let's say deep nested for and if. Okay, how about, yeah. Okay, so what I'm going to do now is make a cube first. So local cube, okay, equals to instance dot new, okay, and in that we have part and then workspace. Okay, so what's happening here is they made a table called instance, in that there is an index called new. If you I think you have gone through the deep table what do you say lecture that we have. So this is just a table which has a function in it, and this function takes two parameters, that is part and where it has to spawn. So we needed workspace as the parent space. Fine, so parent name comes here. So say for example it was something inside the workspace, we would just put that name here, and I'll just show you exactly how. Fine, let me make it now itself, you know, as we are here. So say for example we are here, we click here and we take folder, okay, and then we just right click, rename it to, let's see, the cuber. I know it, I don't know if it is a word. I would like to name it cuber. Okay, and then say for example, let me see if it's working here. Q, no, it won't work here. Maybe a dot would work. Q, yes, see. And one more thing, as I told you, I am going to experiment in front of you so you understand what's happening. So next time a part is created, it works in the workspace, cuber is its parent, so therefore it will be under this folder. So let's just go back here, let's type cube again, and let's give this cube a, let's say what, a size. Okay, so we do cube dot size, and size will take what size it wants in the x, y and z direction. So as you know, vector3 is a table which has a new function in it, and it takes 3 values, so I'll use it as 1 1 1. Okay, so 1 by 1 by 1 will be a size. Let's see what else. Yes, anchored, yes, we don't want it to fall, so true. And we don't want anything to go, no, okay, do one thing, let's do one thing. We'll make it cube dot can collide, if something can pass through it or not, we'll keep it as true, okay, at the moment. And let's see what else. Size, okay, it needs a color, so cube dot brick color, okay, brick color, 1 second, I think that's a comma, dot brick color. This is also a brick color dot new, okay, and let's see what they have. No, I'll use the random function, fine, every time. So let's see, are we done? We have a size. Oh, we don't have its position. So cube dot position is equals to it will take a vector 3 dot new, and it will take we don't want it to be in the center of the screen, because you know there is this, we don't want it in the center. So x, let's keep it in 10. Y, we want it on the ground, so if we put 1 it will be flying, and if we put 0 it will be under the ground, so 0.5 will work, comma 10. Fine, so in x and z it's on 10, otherwise it's on 5. Okay, let's name it. Okay, cube dot name, okay, we'll keep it as 1 at the moment, but it has to be string 1. Okay, so we have the name, position, brick color, can color, anchor, size. Okay, let's run it and see if it is even working. Is it even working? I mean, all that code, is it even? Yeah. Wow. A cube born. Okay, let's come back. Where were we? Yeah. Okay, another thing what I noted is the material. We can change its material as well as the part type. So say for example cube dot type. Is there something called type? No. This transparency part type? No. Okay, what is there? Let's see. Brick color, cast, shadow, glass, collision color. Okay, locked mask, maskless, material, name, orientation, parent. Okay, we can even give a parent separately instead of mentioning it here. So this is an optional field, but then you have to write a complete new line. Offset, position, reflection, size. Oh, we can do a shape. Okay, so this would be enum dot, let's see, what is it? Enum dot part type. Is there something called part? Yes, enum dot part type. Then what? Then what is it? A dot, ball, cylinder, or let's take block. Okay, is that something else? No. Is it like this? No. Okay, let's see if there is an error or if it works. Oh sorry, don't press Ctrl S, just press the run button and see if there is a error or it was fine. Oh, it is there. Okay, so let's see if we have any error because of but I'll show you how we can go in the manual and find out what command we have to enter. Okay, so we don't have any errors, so let's go here and see if it is under the folder. Beautiful, we have it one under the folder. Okay, plastic. What is this? Plastic, material, parent, cuber. Okay. Yeah, shape, block. It did change to block, so we are successfully coding. Okay, now the thing is we have this done. Okay, now I need 1000 cubes. Now this is not the way I can do 1000 cubes. No, this is not the way. So what I do is I write a function cube maker. Let's keep the camel casing thing alive. Okay, and then I'll come down, take this, hit the tab key, enter, end. Okay, now as you know, this size. So size X, size Y, and size Z. Okay, I'm just making parameters, and then for position I want, so one second, what did I just do? Yeah, let's keep this small and this big, keeping the camel casing alive as we discussed. Yeah, so position X, and then position Y, and then position Z. No, small pp. Yeah, who tells that on the YouTube? I can't even remember his name, but I will look his video again and I will mention his name. Small pp, who was that? I know, actually I'm subscribed to him, but it's long time I don't remember his name. If you remember him, comment, that would be good. Okay, so we have a what do you say, function that takes in values. Okay, one second, also we'll put comma name and we will put type. Okay, no, type is a reserved keyword, and also we will put can collide, can call. Okay, so name, can call, and anchor. No, that's it at the moment. Excuse me. So we just want to control this many parameters of this function, and we don't want to change anything else. So name comes here. Okay, so name comes here, and the position, these I'll just copy and paste it here, and then copy this and then paste it here. Okay, So we have, yeah, and then can call, we want this value to come in and be here. Okay, so rest all we don't want to just control it at the moment. This much is way too much actually. So you see how this is a function. Same way in the instance table, this is a function taking parameters. Fine, same thing, same thing, same thing, same thing. This is like a table inside a function or something else. Fine. Okay, so this is how it is. So now when I call this from somewhere, say for example I call this from here one time, let's name it as again one, no, can collide is true. What is that? Yeah, that's fine. Okay, name is 1 and position Z is 10, position Y is 0.5 and position Z is 10, sorry, X is 10, 1 1 1. Okay, we run it. Okay, fine. So let's see if the name everything got in. Let's go here, cuber 1. That's so good. So everything is there. Okay, let's switch it off. I mean stop the game by clicking this button here. Okay, so now we have a function. So if you want to make 1,000, all I have to do is for I equals to starts from 1, goes till 1,000 and with a step of 1, and I'll do this thing that many times till and then end it. Fine. So now all I have to do is, this is the size, this is 10. Okay, starts with 1, so I'll just mention here as I plus 9. Okay, so every time, I don't know how can I add 9 to it. The first time, the second time it is 2 adds to 9, 2 added to 9 is 11, 12, 13, 14. Yeah, that's exactly what is happening. That is so good. Okay, so we'll have I changing each time the value of I changes, and every time a cube is created it will be on the location of I, and instead of this we'll put in I, the value of I. Okay, so let's see if it works. Yo, see, so this is how we understand writing a function and using a for loop. Saved tons of code. I don't want to go to the end of it seeing what happened, but you can see the beauty of this. Fine, but this is not what we want to do. Okay, so now we do is we just keep it to 10. Okay, and now what I'll do is run it one more time just to show you what's happening. Okay, so we have 10, see 10. Okay, and if we go here and open this, we have 10, 1 2 10. That's so beautiful. Fine. Okay, this is what we did exactly with the 1,000. There was nothing new in it, unless I mean the only thing that was is I wanted to show you 10 for for j equals to this is the y value, so 0.5, and let's go till 10.5 with a step of 1, and we'll go to make it do. Okay, and just come here and end it. Okay, so now all we need to do is we have to put in j here. Okay, j. Okay, see now what happens. So what is going to happen is there will be 10 times this and 1 time this. No, this is going to happen 10 times. Every time it happens, this is going to happen 10 times. Wow. So let's see exactly what is happening. So what is happening, let's see. Wow, we have a wall. We have just coded a wall instead of using a modeling tool. Fine. So what we want to see is we want to see how it is actually building. So we'll just put a weight. Okay, and then just see the minimum value. I don't know if 0.1 is even supported, but let's see what's happening. So okay, every time I increases, this happens 10 times, making 10. And so when I was 1, j made 10, then I was 2, j made 10, then I was 3, j made 10. So we have this formed. Okay, this is so good. Just stop it, come back. Now let's see. This is so good. What happens if we put one more 0? I just want to see the minimum value of weight. What happens? Let's see. Yeah, it is. No, I don't think so even it mattered. Fine, I think that's the last one. Okay, now you see what's happening. So now what we'll do is z equals to 10 and go till 20. No, why you wanna have to make it 10? 1 20, no, 1 do. Okay, and then tab it out and okay, and now for the last value I put in z. Okay, now what is going to happen is, let's see what is happening, but this has to be changed. So what we'll do is we'll put I and then put double dots and put some string value. Let me see if I and then j and then z works. Yeah, it works. So basically what is happening is going to add this value with this value and this value and put it in the name place, which is a string, so that we don't have to worry. But j is going to be 0.5, so let's do it in this way. Okay, so each time it is 0.5 it adds, so 1, the next time it is 1, it is going to wait 0.1. okay, then it takes 1. Okay, that's fine. So now let's see what happens. So we have it building. Wow. So what is actually happening is when x is 1, z happens 10 times. J happens 1 time. In that, z is happening every time it is happening. Wow. Do you understand what's happening? Let me explain it to you. So when x is 1, okay, j is 0.5, okay, z will happen 10 times. Okay, so the z is happening 10 times, then j becomes 1, then j becomes it's 0.5 to 0.15, 1.5, 2.5, 3.5, 4.5, 5.5, every time 10 times, and then it comes here. So this is like 1 2 3 4 5 6 7 8. Now 9th, this is I9, and here is like j5.5 or something, and each time j is a value, z happens 10 times, therefore it is making this. Fine, but we don't want it to make in this way because it's so confusing. I don't know if you even understood what's happening. So what we'll do is, let's see what we can do is, we want z. Okay, what we'll do is we'll take this. Okay, first we want what did I even do? Okay, first what we want is we want z in the place of x, so that x happens, j is fine, and x comes here. X comes here. Okay, so now it will look little sensible. We'll understand actually what is happening. Okay, so you see x is happening first, okay, and after x is happening, z is happening. So by changing the x, y and z values, we can change from where it starts and where it ends. Fine, this is good. So we understand a deep nested for loop. Okay, this is so good, but the problem is we also need to understand deep if statement. So for example, I want to use this. What I'll do is, say for example, let's see, it's forming x. First x is being formed, and then y, and then z is happening. Okay, so we need to play with the value of I. Yes, I. Okay, so if I is equals to 1, or 1 second please, or I is equals to 10, only then do it. Okay, now see what happens. See, I don't know if this is work. I'm just trying to make something in front of you, although I did make this earlier, but again it's not in my memory. I'm just showing you how I'll make it from my mind. Okay, so now I is okay, and then nothing happened. That's it. Okay, it is slow. It is slow because there is a wait sign actually. Okay, I'm sorry, we have to remove this at the moment. Okay, now go back. Okay, now let's run it. See what happens. Oh, see, we have two walls. So by just adding a what do you say, if statement, I did not generate the middle thing. Okay, so now let's do one thing. We did this, so let's try to generate a wall, you know, at the end, a 3-walled room. Okay, how do we do it? So we understand that when I is 1 and 10, do it, fine. So otherwise don't do it, correct? Okay, so let's see if I want to make this is I1 when that wall happened, and I10 that wall happened. Okay, so every time I happened, Z changed. Okay, let's see. Okay, let's do one thing now. What we want is okay, let's see. I might change the complete code because see, I'm making it in front of you. Okay, I'm just experimenting. If let's see what I want to give. If I want it to make the last one I J Z, Z is 10. If Z is not equal to 10, then do in this way. Okay, otherwise else do it anyhow. Okay, let's see what even this does. I don't know if it will work. It just came in my mind to try. I'm just trying it. What happened? Yeah! Oh wow, it was just a try, but I did make a room. I mean, the people making 3D models might be making plans to kill me. I mean, I'm showing coding to make models. I mean, is that even a crime? No. Well, let's continue. Okay, so we are successfully, we have this. Now let's see if I want to create a only generate this much. Let's see. Okay, so we have this and we have this. Now what we want is if Z is not equal to 10, then this happens. Only then this has happened, otherwise the back wall was there. Now in the X, I want X to happen. Okay, now what I do is I write if J is not equal to 10.5, the last value, then do it. Do all this. Fine. In case else, if it is something else which is not, which is 10.5, I mean, in that case there is no called J, a small letter J. Okay, then just do it. Let's see now what happens. Okay, now let's see what happens now. Yeah, we also have a wall. So see, we successfully reached till here. Now I want to put some more challenge and make a door. Let's make a door. Okay, to now make the door, should we even completely change this? There are times where we will have to change this completely. You know, it happens. That is why I'm making this as an example, so you understand that it does not matter how many times you have to change the code till you solve it. Maybe the approach is something like that, that we cannot make a wall now. Let's see, let's analyze if we can we can make a door. So for that, what should happen is, if I is equal to 2, let's do this much first. fine, else just do it. So now let's see what happens. No, we have something strange happened. Wow, but we did make a strange, wow, we can use it to, you know, use it into architecture design or something where roof comes out a bit. See, although it did not work, but we did learn something, you know, we can do that. Okay, so if I equals to 2, then do it, otherwise then don't do it. Okay, so what went wrong is, no, we are wrong. Not I. The I is fine. I1. Okay, we want it to completely cover the top one. Okay, how do we do it? Okay, I'm taking time because I'm just thinking. I1, it's generating that's that wall. I2 is generating that's that wall. Now I don't want anything inside to build, but just the top wall, which is on position 1 actually. No, not position 1. Position 2, 3, 4, 5, 6. It's on everything. Okay, how do I do it? Okay, let's come out of this statements. It is from here. Is not equal to this happened, this happened, this happened. Now, okay, I think we have to change the complete code. See, this is what might happen, but let's try to still fix it without changing the code if there is a way. So if I equals to 1 or I equals to 10, then this is being done. That is fine. Okay, now our challenge is else. Let's put another condition. Else if I okay, just we want the first block to come and we don't want any other block to happen. So this is what we want is the first value of, let's first see how it's building. Let me just see how it's building so that I can understand it much better. Let's end it here. 1 second, hold, save it. No, don't save it, just put a wait sign. Wait, here it comes. Wait, so okay, this is happening when, okay, so it is starting from here and then the J value is increasing and then it starts from here. Okay, it's skipping it from here, so that means what is the name of this block? Let me just see. So I'll just go to home, take the select one, take the first one. What is this? What's the name? Name 6111. So that means 6111, or it means 6. I is 6. Something is 11. That is okay. Something is 11, and then Z is 1. So that means Z is 1 there. On here Z is 1, so I understand Z is 1, and if Z is 1, okay, it's so confusing. I'll just pause it, solve it, so that you know you don't have to watch all those things that I'm doing. Yeah, so all I had to do is I had to write if Z is not equal to 1 after analyzing a few names, and then at the end just this much. Fine. So only this much of code is added, an else and an if. If it is not equal to 1, just do this. Every time Z is equal to 1, do this. So now see if what's happening. What we'll do is we will change this to 2. Oh my god, we have to do it this many places. Okay, what we'll do is we will local can call bool equals to false. Okay, can call bool, we'll just take it, come here and drop it in here, here, here and here. So next time we just need to change this and our job will be done. So now let's run it instead of just removing this weight. Okay, now let's run it. So wow, we have it, and we can go in and yeah, it is empty. So we have successfully made a room. Now we have to cut a hole in it. So I mean a door in it, not a hole in it. So as we see, this is z equals to 1 here. Okay, this is what we found out, that this is z1. So every time z1 is happening, this wall is being formed. So we come here, this is somewhere we should not touch because we want when z is 1, which is here. So as soon as z is 1, what we will do is we will try to see what's happening. It's making on z, we understand, and x we understand, and what else? Yeah, what we can do is now is, say for example, we write if I, okay, the value of I, let's say I is greater than, there are 10, right? So 5, or 5 is greater than, no, I is lesser than 5, lesser than or equal to 5, or I is greater or equal to 6. No, wait, just keep it 4, 5, 6, 7. Let's start from 4. Yeah, 4 is okay. 4, 5, 6, and let's keep it 8. Then only do it. Okay, otherwise don't do it. Then don't do it. Okay. So now let's see what happens. Have we made a cut in it? I don't know. Yeah, we did make a cut. See, but we need a door. We don't want this, but yeah, you can even use it for some old castle which has something like this. Wow, it's beautiful. Anyways, let's come back, stop it. So now we know this is working, but we also need to add in condition. We want this to only happen, okay, if if j is less than or equal to 5.5. Then do it. Then check this condition. If it is above, just don't just don't check anything and make this. So now let's see what happens. Okay, now let's see what happens. Yeah, we have a successful door. Is that okay? That's it guys. Anyways, I'm not feeling even funny today. I have some flu going on. Okay, so I think this much is enough for you, but it looks dirty. Here it's just two blocks here and 3 blocks here. This we need to fix this. Fine. So all we do is we just stop it here and we increase the value of I, okay, and j and z. Z. Okay, now when we run it, what happens is, yeah, this is more. 1 second, is that, what is that? Wow, see, you can use that. Wow, I didn't see that. See, okay, so we have a roof, a good roof, and we have something extra here which we don't want. Okay, why did this even happen? I understand why this happened. See, this happened because if you see here, we did not change the values here, so that's what had happened. So this becomes 11, this becomes 11, and then this becomes 11, and let's see what else. That's it. I think rest all becomes, I mean, is kept how it is. So now let's run it. So we have a perfect roof. Okay, so now let me show you something. If I want to make the roof a bit down, okay, all I need to do is I just type in here 9, say for example, okay, and then when we run it, what happens? Let's see. Always experiment, always experiment. Let's see what happens if we go in. See, roof is much lower, and if we jump on the top, see what's happening. Do you see? Okay, so you can put in by using this, you can add in a roof with fencing. Is that so cool? Fine. So now everything is properly working. So this, I think, is a great example of deep if nested. Fine. Many conditions inside it, a good function, and a nested for loop. Fine. Okay, this is one of the method how you can create. Other method is using the name. Okay, now we know each we have used this to make a name. This string is formed by adding the I, the J, and the Z value, and is giving each cube a unique name. So what we can do is we can generate all the cubes as we did first, 1,000, 100 by 100, 100 by 10,000 bigger cube that we made first, and then we use this to cut out. But what we can do is we can use the name and find all the names that we want to cut it out, and we can destroy those objects. Even that can be done by using names. Fine. So that is why I kept the name. So you can also do things by using the names. Let's say for example, I'll give you an example right here. Let's come out of all this if statements. So where this is let's close it. Okay, now close this. Okay, so we are done here. So let's come here and let's open it back. Okay, so let's come here, and now what I do is I write if, say for example, name. No, then what I have to do is, after this is done, I have to write another for loop for, okay, I comma v, cube in I pairs, in pairs, and here I will write, let's say first I'll come here, local cubes equals to, let's see, workspace dot cuber get children. So we'll get all the children's, put it into a table, and this becomes a table. So then we write this cubes here. Okay, so for this do, okay, so now we know each time. Okay, let me explain what's happening here. What we'll do is we'll print cube dot name cube dot name. Yeah, no, let's not put cube here, it might get confused. Just write C. Okay, and did we, okay, that's it. Okay, so now when we run it, you will see that it did what it had to do. And if we go in the, where is it, the view, yeah, okay, we see every cube with its name. See, fine. So now what we can do is we can just stop it. Okay, now we know that this is happening. Okay, so our naming happens by adding these values. Fine. So what we do is we take this, we copy it, come down, and then I'll just remove it because you understood what's happening. I'll just close it and press enter here and end. Oh, that was good. And then enter and then enter and okay. So now what we do is we type in see if c dot name is equals to, say for example, equals to, and we take this, copy it, fine, equals to this, say for example, okay, then destroy everything. Let's see what happens. C dot destroy. Okay, so I think nothing should even work because everything should get destroyed or nothing will get destroyed. Let's see what happens. Nothing. See, everything destroyed because our condition is if everything matches, destroy everything. This is not what we want. Okay, but now what we will do is we will come here and write if I, okay, let's come back here, copy some intelligence out of here. So what we did is z is not equal to 1 was our first line, so we come back here and we type if z is not equal to 1, then do this and okay. So let's see what happens. Let's see. I don't know even what will happen. Let's see what happens. We have, wow, see this? Okay, so let's come out and let's see what is the mistake that we did. So every time z was not equal to 1, this happened. But why did it leave a line in between? You see, let me show it to you. What happened with us is we did achieve something, we are going on the right direction, but we lost this line. Why is it happening? So what it did is, see, we did even lose a block here. So somehow, I mean, this should not even happen unless we are making a mistake, and that is, this is correct, this is correct. Yeah, we just copied from there, these are correct. And if it is not equal to 1, just come here and check if I, j and z. So if z is not equal to 1, this would have never run. So therefore we would not have lost the first line, but we did lose it. What is happening? Aha! Z, is this the problem? Let's see. I think the back wall. Aha, now we have the side wall left and rest all removed with one block, making an issue there. Okay, let's change it to I, which is correct actually, and z, okay, and destroy only if z is not equal to 1. So this did work, okay, and whenever it was not equal to 1, it did not destroy. So rest everything it destroyed, but we still have an error, that is we did lose a line on the top. I have no idea why even that happened. I'll figure it out and I'll update in some other video, but I think it's enough for you to now understand that we can even use this command to get all the children into a table, use the for loop, go through all the for loops, and use the name to create designs. Fine, use the name to create designs. I think this j plus 0.5 is causing something, but then this name will not match unless this is equal to 1. So therefore whatever happens, that line should not have been destroyed. That is what I understand. But what is happening? Oh, wait a second. Say for example, if it is equals to 1 only, then run. Let's see what happens now. Always experiment, you will find out the issue. So we have everything else except the front wall without any error. Yeah, this time no error happened. See, this time no error happened. We have everything perfect, just not the first wall. So yeah, we did reach somewhere. Okay, we did reach somewhere. So what we need now is else. Say for example, if it is not equal to, no, if it is equal to 1, destroy everything. Okay, no, actually we don't need this. So now we need to figure out a way that only if it is okay, if it is 1 it is happening. Okay, so with this what happened is we were able to destroy the front wall, but now let's do something like, then we want a window to happen, right? So let's see, after z is equal to 1, check if x is if I is greater, less than or equal to 2. Greater. Yeah. Let's see what happens. Or I is greater or equal to 4. Then do it. Let's see what shape comes up, then we can modify it. We will reach somewhere. I just want to make a window. That's not going to be that tough. What? See, but something did happen. Okay, so what happened, I'll tell you. Anything that was less than 2 got destroyed, and greater than 4 got destroyed, greater or equal to 4, so only 3 remained. So everything except 3 remained. So we know by I we are able to manipulate the front wall. Fine. Okay, so this is so good. So I think let's now try j. Say for example, we give a j, condition j, that if it has to be greater or equal to say 5.5, or I should be less than or equal to 7.5. Okay, in this case what happens, let's see. I'm doing in front of you so you understand how real coding is done. See, something strange happened, but we have some kind of structure. See the limit. There is no limit we can modify. See, okay, so now what we know is when j is in a certain value that is remained, rest all got destroyed. Okay, rest all got destroyed. See, the difference between this loop and this is creating, this is destroying on conditions. Fine, so it will be opposite. So when j was greater than 5.5, first it saw if z is equal to 1. Only when z was equal to 1 it came in, rest all it did not touch anything. It came in and saw if j was greater or equal to 5.5. So it did find j to be greater than 5 and 7.5, only then it destroyed. Rest all it yeah, so only these ones got destroyed that were greater than 5.5 or less than 7.5. Let's change this and see what happens if I make this here and this here. Probably some stupid thing I wrote, even let's see what even happens. Always play with numbers. Wow, we have something strange again. See, fine. I mean, I can go on experimenting, but let's see, we are reaching somewhere. Now we understand we are able to manipulate by J, but that's not giving us that good results. So I think the key is in I. Yeah, I. So what we'll do is, if I is greater or equal to, say for example 2, let it be just greater than 2, or I is less than 4. Okay, then what we'll do is we'll give another condition that we want it to be on a height. That is, if J is greater than 5.5, or not, or I think now we have to use this and J is less than 7.5, then only do this, then only destroy, otherwise don't destroy. So now let's see what happens. See, we have a window. We do have a successful window, but let's see, did we destroy any other thing? No. So we have one window here. Fine. Okay, now let's see what went wrong. So 6, only the thing that was 6.5 got deleted. So let's make it 4 and let's make it 8. Okay, now let's see what happens. Yay, we have a window. Let's move it on the top, don't we? Fine. So we understand that it has to be 7.5, and this has to be 7, 8, 9, 10, 10.5. Okay, now let's see what happens. Okay, we have a cut on the top, 2 blocks gone. We need this 2 blocks to be gone as well. Hold down please, I'm going to cough. Okay, so we successfully made it, but we also want something more. We want it to we need 4 blocks, so we also want the 2 more blocks on the right to be removed. So let's see how we'll achieve it. So this is working fine. Okay, this is okay, this is working fine, and then this is working fine. Okay, as soon as this is working, all we have to do is we have to just write it 5. Okay, now when we run it, we have a window. See? Okay, so now say for example we want another window here. All we need to do is, we saw 1 2 3 4, okay, 5 6 7 8 9 10. Okay, 8 9 10 also needs to be removed. Fine, 8 9 10. So this is a condition here. Okay, 8 9 10. So we just put it into a bracket, or, and we will just copy this and paste it here. Okay, and now what we'll do is 8 9 and 10, right? 8 9 and 10, so less than 11. Okay, now let's see what happens. See, we have 2 windows, but wait, we okay, I think we don't need that to happen. Yeah, you understood what to happen. So this goes 10, and now let's run it. Bravo, fine. So we have 2 windows and a door cut. Okay, so we learned 2 methods. Okay, one method is to create using this way. Okay, we use the loop, and as we create we cut. So this is how we made the walls and the door, and this is how we made the windows. Fine. So I hope this was one of the unique tutorials that you have seen such deep for and if happening, and one removal method and one creation method. So I'm sure you're happy. You don't need to give a feedback. Thank you so much. Bye bye.